talking about compound interest today, and we're going to be doing an example. So we already have our formula for compound interest, and that's the amount equals the principal amount, and then we have the rate here and the number of years or periods or how often it's compounded. So we're going to match each of these to a part of a problem. So we're going to say that there was a principal amount, the initial amount that was put into an account. It's $20,000. Then it was borrowed at a 6% rate, 6%, at a 6% rate for 3 years. So now we need to match each of these up with parts of the equation. So the P stands for the principal amount, also known as the initial amount, also just what you put in at the beginning, what was initially put in. So we know that 20,000 was put in at the beginning, so that's going to be our principal. So we're going to say that our principal is 20,000. Then we're going to find our rate here, and the rate is how often it's being or how much it's being compounded. So that would be 6%, 6, and then we're going to do the time. The N is also time, but it stands for the number of years or the time period. So we'll do an N equals 3. Okay, so now we're going to set this up. So our amount equals the principal amount, which is 20,000. And then we're going to do 1 plus our rate, which was 6. And then brought to the power of 3. So we're not quite done setting this up because we always have to make the rate into a decimal. It's very important. The rate always has to be a decimal. So 6 as a decimal is the same as 6 over 100, which is also the same as 0.06. So we're going to go ahead and put that in here. So we have A equals 20,000, 1 plus 0.06, and then a 3. So now we're going to combine this part. And we're going to do A equals 21.06 to the third power. And then all we have to do from this point is solve it, or we can plug it into our calculator or whatever. So we're going to take take this to the third power because exponents comes first in PEMDAS, and then we're going to multiply it by our initial amount. So we'll end up with let's try this one. We'll end up with A equaling 23,820 and 32 cents. So I'll end up with $23,820 and 32 cents. That's our amount.